This is 2 through 7, and I'm just going to go right down the line here. 1, 2, 3, 4, or 2, 3, 4, 5, 6, 7, like this. We've got 3 cards, so there's 3 outcomes every time, and we're going to do some complex probability. The first one is, and the O's, they're not zeros, they're odds. So the first one is probability of odd, then even. Okay, so odd, we've got 2 out of 3 chance. Even, we've got 1 out of 3 chance. Times those together, we have a 2 out of 9 chance. Okay, I'm going to skip to 6 because it's going to be the exact same thing except for in a different order. The evens would be 1 out of 3. The odds would be 2 out of 3, but in the end, you still get 2 out of 9 no matter what, because you've got the same odds for both. All right, now we've got even and even. Okay, it's 1 out of 9, or not 1 out of 9, it's 1 out of 3 for evens here, and then if we do another set of evens, it's still 1 out of 3. So that's going to be 1 out of 3, 1 out of 3, which is going to be 1 out of 9. Down here, odd and then odd. The chances of an odd are 2 out of 3. So our first time it would be 2 out of 3. To get another odd, it would be 2 out of 3. Multiply those together, and we've got a 4 out of 9 shot of getting 2 odds in a row. So that's by far our best chance. That's almost a half chance right there. It's almost 50-50 that it's going to happen. Now we've got 3 cards that we're going to draw. Odd, even, odd. Okay, and this is 2, 3, 4. This is number 5. So for odd, we've got 2 out of 3. Even, we've got 1 out of 3. And then odd, again, we have 2 out of 3. So again, we're just multiplying straight across. 2 times 1 is 2, times 2 is 4. 4 out of 3 times 3 is 9, times 3 is 27. You can also think about 3 times 3 times 3 as 3 to the third power, or 3 cubed that we've talked about before. So 4 out of 27. And the last one, if we have all evens, and we do 3 times in a row, it's going to be 1/3, 1/3, 1/3, which is going to be 1 out of 27. So that's by far our closest probability to nothing, would be 1 out of 27. The best chance we have on the board is our 4 out of 9 right here. And remember, to find the percentages of these, all you would have to do is top divided by bottom. So I'll just do one of them for you real quick. I'll do the highest one we have here, odd and odd. 4 divided by 9 is all I'm looking at here to do. 4 divide 9 on a calculator, and I get 0.444444. Lots of 4s, okay? Remember, we can write that like that, 0.4 with a line over it because that's repeating. But for a percentage, we just need the first 2 numbers, so we would just say 44% chance, almost 50% chance of getting this odd and then odd. For 8, we're using a restaurant menu that's made up of side dishes, main dishes, and drinks. They want to know the probability of ordering an egg roll, sweet and sour pork, and juice together. So all we have to do is get the number of outcomes for each separately. So if there's 4 choices for side dishes, that's 1 out of 4. 1 out of 4 chance of which one they're going to pick. Main dishes, there's only 3 choices, so that's going to be a 1 out of 3 shot there. And then drinks, 3 choices, which is going to be 1 out of 3 also. Now, drinks is interesting because like one of the choices is soda, so they lump all sodas together. They could have 10 different kinds of sodas, which if we listed all of them would drastically change this. Or they maybe have tons of kinds of juices, but they're just lumping them all together into one, so we'll just keep it at 3 outcomes. Okay. Now all I have to do is multiply my numbers together. So I have 1 out of 4, 1 out of 3, 1 out of 3. That's going to be, if I times them together, top number is going to be 1. 4 times 3 is 12. 12 times 3 is 36. So I have a 1 in 36 chance, if everything's even, of ordering egg roll, sweet and sour pork, and juice. And actually, if you think about it, I can pick any 3 things on one thing here, one thing here, and one thing here. It's always going to be 1/4, 1/3, and 1/3 in this problem, which is going to be 1 out of 36. If I want the percentage, that's just 1 divided by 36, and it's going to be 0.02, lots of sevens. So we could just circle the first two numbers. That's 2%. This is a 7, so we probably could round that up. So maybe we even say like there's a 3% chance of getting this particular menu for this one. Another thing you can also get out of this is if you have something like this and it's like choices, you have 36 different choices of side dish, main dish, and drink combinations. That's another thing to think about too. In the end, we basically have 36 outcomes because there's 36 choices in combinations with these three categories. Number 9 is kind of an interesting problem because we're trying to think if a family has 5 kids, what are the chances that are all girls? Well, actually, if you think back to the last video or earlier in this part 2 section, we had a problem where what was the probability of flipping 5 tails in a row? This is actually the exact same problem because the probability of flipping a tail and the probability of having a boy or a girl is exactly the same. It's actually half, or 50-50 chance. So this would work the same way. So the probability of getting all 5 girls. So the first time you had a kid, it would be a 1 out of 2 shot of getting a girl. 1 out of 2, 1 out of 2, 1 out of 2, and 1 out of 2. Okay. Times them all across, that's going to be 1. The bottom number is going to be 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So we would, again, just like the coin problem, if we had 5 kids, 5 girls is going to be a 1 in 32 chance. Okay, so not a very good chance of having 5 girls in a row, but it can happen. It's not a 0 probability. It definitely can happen. All right, for the spinner problem, we've got a couple of sections with red, we've got a white, and we've got a green. And we're trying to find the probability. So altogether, all you have to do is count. We've got 4 outcomes. So everything we're going to do is going to start to be out of 4. So to get 2 white, okay, first time we spin, we've got a 1 out of 4 chance of getting white. Second time, we still have a 1 in 4 chance of getting white. Times those together, and we have a 1 in 16 chance of getting white and then white back to back. Probability of getting white and then red. White is going to be 1 in 4. Red, you've got a little bit better chance. Red is 2 in 4. Multiply straight across, we'd have 2/16. We can reduce that down, thinking of fractions here. 2 goes into both of those, so I could have 1/8. And then the probability of not getting any reds on 2 spins. So the probability of not red and then not red again. Okay, the probability of not red is 2 out of 4. The probability of not red again is still 2 out of 4. So we have 2 out of 4 and 2 out of 4. That's going to be 4, and that's going to be 16. Again, I can reduce this down. A lot of 2 can go into this, but let's use the biggest number possible. 4 can go into both of these. Divide by 4, and I get 1/4. So here's my chance here, here's my chance here, and here's my chance here. If I wanted to figure out what those actual percentages is, I just do top divided by bottom. So I can start with the top. 1 divided by 16 comes out to be 0.0625, which is just 6%. 1/8, we do 1 divided by 8 is going to be 0.125. So I'm going to write this down here. 0.125. And if you think about it, that'd be like 12% about, or you could even round it up to 13 probably. We'll just say 12%. 1/8 is half of 1/16. And if you look at the percentages, 12%, 6%. Okay. Same thing here, we got 1/4. Okay, 1/4 is half of 1/8, so we would expect this to be about twice as good of a chance here. So if I did 1 divided by 4 on my calculator, I come up with exactly 0.25, or 25 hundredths, which is 25%, which is about double of this. So our odds keep getting better every time.